Our Anteromedial ACL reconstruction module tracks a series of metrics. Precision scores are generated if users skip no steps in the process. We're measuring 4 different aspects here to determine the precision score. How well you place your mark on the lateral femoral condyle, your femur drilling exit point, as well as your depth reamed, and lastly, the tibial tunnel entry point. We're going to go through this module and showcase where each of these variables occur, as well as highlight some educational aspects that are worthwhile to teach your students and showcase. The take-home message in this module is use sawbones to your advantage. At any point that you can pull out the bones, encourage your students to do so. There's lots of valuable knowledge that can be gained from seeing things in a different perspective that can't otherwise be gleaned in reality. There's a need to mobilize the knee joint in this case, and we allow you to do so. You can grab it and manipulate the distal extremity as you see fit. We're showing the angle of flexion as well as varus and valgus measurements here. This ACL reconstruction is arthroscopy based. We have an arthroscope that users can insert into the joint and visualize the anatomy necessary throughout the case. We're also going to be using a shaver to remove the remnant ACL footprints, both on the tibial plateau and the lateral femoral condyle. Use of this shaver requires users to triangulate and use 2 tools at once within the portal. I'm now going to insert this all in through the medial portal to mark out a spot on the lateral femoral condyle that I'm going to use to drill my femoral tunnel. I can also pull the bones out of the body here and visualize it close up to see where those remnant tissues still exist in full 3D visualization. As is required in this surgical procedure, I need to hyperflex the knee. I can do this while the scope is still in and visualize how it shifts and changes the joint space. I'm now working on placing the guide for my femoral tunnel, and I can grab and move this on scope to see how the angle is going to be adjusted. One very powerful tool, however, is I can pull the bones out of the body and do this outside to really see what I'm doing. Coupled to this, there's a green mark you can see on the lateral side of the femur. This would be the exit point for my tunnel, and as I'm adjusting this tool, you can see how that reflects my positioning. I'm now going to use this pin to try and measure the aperture to cortex length of the femoral tunnel. When I grab it, I can move it up and down, and I can still do this in sawbones mode. Working to insert this tibial footprint guide. As you can see when I insert the scope, we've got guides here that are helpful hints to show new users where they need to place the tip of it. That's the green highlighted sphere on the tibial plateau. I'm now going to move the guide into position to align with the mark shown on the screen now. I've placed a tibial guide pin, and now I need to ream. This is another tracked step to showcase how I've done in terms of placement of this tunnel compared to the ideal. I also need to capture sutures in this case. I can use arthroscopy and try to grab at it with my graspers, or I can pull the bones out of the body and do this in more of a free-form sawbones mode. For an ACL reconstruction, there's a need to deal with sutures and graft constructs. We do this in VR by allowing users to pull on strands to mobilize and move the graft as needed. Overall, in this case, I've been given a 60% precision score because I skipped none of the steps. My all-mark placement was contributing to a big deduction of my score, as it was pretty far off from the ideal. My exit point was good, as well as my tibial tunnel entry point, and the length of my femoral tunnel was a little bit too short. But overall, these metrics give me feedback, and I know how I can improve for next time. I can also compare my score to the final view of the graft construct when I pull it out of the knee.